All right. So first thing first, since I have two students in the class, one is new, one has been with me for some time. So question to you, Prisha, what do you know about complex numbers? And again, I mean, if you know about it, wonderful, you can share that with me. If you don't, it's okay. I mean, that's why we are here in the class.
I don't know about all of them, but I know like eyes. What like the eye symbol is one of them, and it just means the square root of -1, or the negative square root.
Okay. So then probably, Dave, it will be a recap of what we have done so far. And my request to you guys would be, since we don't have a lot of kids in the class right now, let's use this class to ask as many questions you want, so that we have no doubts with respect to what we learned. Okay. So Dave, would you recall what all we have covered so far with respect to complex numbers, or?
I remember we graphed it.
Okay.
We divided.
Okay.
And yeah.
Okay. So let's start with a quick recap of what we have learned, and then we'll try relating things one by one. Okay. So when we have to find out square root of 25, anybody and everybody can say that it's 5. That's easy peasy, no worries. If somebody asks you to find out square root of 4, you know that you will get 2. Even if you have been asked to find out square root of, let's say, 12, you know that this is not a perfect square, but you still have ways to calculate it, correct? It'll be something like maybe 3.21 or something square will get you close to this. You have calculator which you can use to find that out as well, correct? Life gets a little more interesting when we have to find out the square root of a negative number. That is where, when we started learning quadratic equation and finding out values of x from a quadratic equation, we came to a roadblock saying that, okay, if I have a negative of a square root, that is when I will say I cannot find it out, because there is no negative of a square root. Okay, that was a roadblock, or that was maybe a point where we paused. Now mathematicians did not stop. They said, no, we cannot stop it here. What they said was, okay, this is a problem. If you have to find out square root of 6, you know how to find it out. Our problem is with this minus sign. So can we separate that out and still see if I have a way to go forward or move forward? So that is how this square root of minus 6 became square root of -1 times square root of 6. So with all the possible ways that we have learned or that we know of, we can find out the square root of 6. Our problem was with this guy. Any negative number is a multiple of -1 times that number. So -1, if we separate that out, our problem seems to get little simplified. So that being said, they said, okay, fine, we have to find out square root of -1, and then let's say square root of -6, square root of 6 is maybe 2.3 or something. I'm just making it up, okay, without trying to calculate the exact value. This guy, square root of -1, was given a name that, like, when we said that, okay, if I have to find out square root of minus a negative number, that's an imaginary number. That means I don't have a realistic solution. They said, okay, fine, if you're calling this an imaginary number, let it be an imaginary number, and let's give it a name. So square root of -1 was given a name I, which is the acronym for imaginary number, right? So that is how this took birth. Is the story okay? Okay. Now, so now when we got at least a mindset to look at any number where you are dealing with a negative of square root, we said, no, we are not stopping. We have a way to define it. We can take out the -1 from it, or square root of -1 from it, and then find out the square root of the positive number that we are left with. That at least gets us going without saying that, oh, hey, I cannot move forward. That is how the whole thing started. Now, again, if you relate back to what we know about the number system, we have learned about different numbers like natural numbers, whole number, integers, right? Then we learned about fractions, decimals. We learned about the what do you call, the recurring numbers also. Like if you're talking about 22 by 7, which is a pi, this doesn't give you an absolute value. It becomes a recurring. It has a fixed and a recurring component to it. So likewise, all the numbers that you can plot on a number line, those were given a name, saying 0, 1, 2, 3, 4, minus 1, minus 2, 3, 4. Then you have decimals, square roots in between, the fractions, whatever you call it. This entire set, or the gamut of numbers that we have to deal with, they were given a name, real number. So anything that can be realistically plotted on a number line was given a name, real number. So now, where does the imaginary number fit in, and how do we deal with that? So they said, okay, fine. When you're dealing with a number system, you can possibly have two elements to it. One is the real component, and then the imaginary component. Real component, imaginary component. This thing together was given a name called complex number. So when you're talking about any number which has real component and imaginary component to it, that was given a name complex number. That is the main what do you call, main topic or the unit that we are trying to cover as part of this unit. Okay, so now real number had anything that you can plot in a number line. Imaginary thing that we learned by dealing with the negative of square root of a negative number. So essentially, to define a complex number, let's say we call it C or we call it a Z, it is given a standard form saying A plus IB or BI, whatever you call it. A is your real component, this one is your imaginary component, and A could be any number that you can think of, 1, 2, 3, 4, 0.15, 1 by 6, 2 by 9, whatever is part of a number line. Now that can be plotted on number line. This is the component where this is your real piece which gets multiplied with the imaginary number. Okay, so this is any complex number. If you hear a term complex number, you should safely assume that it is actually something like Z, which has a real component and an imaginary component. Let's say if A is 0, then this complex number has only the imaginary component to it. If you assume that B is 0, then this, even if you call this a complex number, this imaginary component is 0, so you have only real component. So basically this becomes your superset. Any and every number can be represented as a complex number, and you will term it real or complex depending on whether you have the imaginary component to it or not. Is that part okay so far? Dave, I know it's a repeat telecast for you, but still, yeah?
Yeah, it's good.
Okay, now see, the problem with math is you cannot look at things in isolation. Everything is tightly linked with other concepts that we know of. So now, let's say if you know about, we learned about number line. We did not stop at this. We said, okay, no, let's put another number line which is perpendicular to this, and this became our coordinate plane. This is your x-axis, this is your y-axis. Correct? So where does this complex number fit in this schema of things? Now, complex number was, first of all, it was an imaginary thing that came into play. So it was decided, okay, fine, you will not try to plot a complex number in a real number scenario where you're dealing with two number lines. You will give it a different name, and you will say this is a complex plane. okay, where your x coordinate or equivalent to x coordinate will be your real coordinate or real axis, and whatever is your y coordinate in the equivalent coordinate plane, that was given a name saying this is your imaginary axis. So this is a real axis, this is an imaginary axis. When you look at these two together, this is called complex plane. So this is nothing different, just that your complex number has two parts to it. It is just related with the coordinate plane that we know of, saying fine, this is your real coordinate and this is your imaginary coordinate. This is something that will be plotted on the imaginary coordinate or along the imaginary coordinate. Is that making sense so far? I'll keep asking you guys, okay? Because otherwise I get a feeling that no, I'm teaching myself. So I'll keep nagging you guys a little bit, but just bear with me. Okay. Now you can always relate this with the linear equation that we deal with, right? Whatever value you have along the x-axis, that's what you plot here. Whatever value you have on y-axis, that is what you plot against this one. Similarly here, this is your equivalent of the linear equation. Now let's not confuse ourselves with the linear equation. I'm just telling you guys that no, these things are relatable, so we will not look at them in isolation, and it always reaffirm that okay, what happens to our coordinate plane if I'm talking about complex plane, right? So this is the correlation. Now how do you plot this? Whatever value, let's say this is my real axis, I'll say 1 2 3 4 5 6 minus 1 minus 2, and you can always choose your units. Here I'll say 1 2 3 4, and here I'll say minus 1 minus 2 minus 4. Okay, so if I have a complex number in this form but written with absolute value, let's say 3 plus 2i, if this is my complex number, if I have to plot this in the coordinate plane, how will I plot this? Dave, do you remember how will we plot?
Yeah, we would use the x has on the x-intercept and the complex number on your y-intercept.
Correct. So you will see this is your real component, which will be on the real axis. So this is my I'll be having a number along this line. Anyways, so and then I have 2i. So 2 against the positive on the positive side. So 2. This is my I axis for I, and I'll pick up the point 2. So this is my 2i. So this is my point that I get by plotting this complex number in the complex plane. Prisa, is it making sense so far, beta?
Yes, sir.
Okay, all right. So this is how we plot. Now we can play around with this. Now let's say if I have two complex numbers, let's say this is my first complex number and this is my second complex number as 6 plus 4i, let's say. I'm just creating complex number at will, okay? So 6 plus 4i, what will be the point? 6 here on the real axis, 4 on the complex axis. This is the point. So I have two complex numbers. This was my first complex number, which is here, 3 plus 2i, and this is my second complex number, which is 6 plus 4i, which is here. No confusion with respect to why I've chosen those points, correct? Okay. Now you might come across a situation where you get a question saying find out the midpoint between the two complex numbers. So look at this, midpoint between the two complex numbers. When you're plotting a complex number, that essentially locates a point on the complex plane for you. You have plotted two, so it's saying midpoint, meaning there are 2 points, you join them, and this is essentially asking us to find out the midpoint, meaning which will be falling halfway through the 2 points. So how will you find the the third number which is the midpoint, the third complex number which is the midpoint. Any guesses, any thoughts?
Wouldn't you just follow the same step except move further into the complex plane?
So here the situation is little different. Here in this case we had the numbers given. This was my first complex number, this was my second complex number. So I have the complex number given and I had to plot them. So we plotted them. Now we are saying that okay, you have two complex numbers that you have plotted. Find out the midpoint between the two complex numbers. So you have to take the information that you have, and using that information you have to find out your Z3 in the A plus BI form, and correspondingly find out the value of A and the B.
So would you use the midpoint formula except using Z1 and Z2?
Yeah. So okay. So that is one thought. Dave, do you remember what we discussed last class also?
Yeah, I remember, sir.
Yeah. So tell me, teach me now.
Okay, to find the midpoint, we would basically just, like do 6 plus 3 divided by 2 to get the x, middle of the x.
Right.
And then we would do 4i plus 2i divided by 2, in
Right.
the middle of that,
Correct.
and then that would be the y.
Right. So I mean that will be your. So basically it will be 6 plus 3 by 2 will be your the value of A, and 4 plus 2 I divided by 2. That will be your B part of it. So it becomes 6 plus 3 by 2, 4.5 plus 4 plus 2, 6 by 2. 4.5 plus 4.5 plus 3i. That becomes your the midpoint. Right, Prisha? So it will just be the average basically.
So
Now,
aren't you just using the midpoint formula?
I'm sorry?
Aren't you just using the midpoint formula for that?
See, there are two ways of looking at it. It's more of a visual thing, okay? So, see, when you're talking about the complex number, you're essentially looking at real component as one and imaginary component as the other piece of the midpoint, right?
Yeah.
So basically, any point that you look in the put in this complex plane will be in the form of A plus BI, okay? Everything will have a real component as well as an imaginary component to it, okay? So likewise, your midpoint will also have the same thing, A plus BI thing. Now, what will be the value of A and what will be the value of B? That is what we are trying to find out. See, you will not do mix and match here. You will put the real thing together, find out the average. You will put the imaginary thing together, find out the average. That will be a midpoint. Now, there is another way of looking at it without stressing yourself too much. Now, if you look at it, look at the visual part of it. Okay, so see, if you just draw perpendicular from these points onto the two axes, right? This guy has the midpoint, right? Now, if you look at it visually, right? This is going to be your the real component, and this is going to be your imaginary component, correct? For the midpoint. Now, if you look at it, this is the midpoint. So this is the average of this length minus this length minus this length by 2. Or sorry, you can, I mean, that will be the distance. So you can say this length plus this length by 2. That will be at this point. Likewise, here it will be this length plus this length by 2. That will be at this point. Okay. So you can visualize it that way also. So regardless of where your complex point numbers are, it could be here also. So you will just, let's say your first point is here and second point is here. So you will visualize this as okay, this is my starting point, this is my ending point. So midpoint will be somewhere here, which will be half of this length, and your this one will be like it is half of half between this point and this point. Correct? So basically you have to always see, memorizing formula is a very difficult thing. Okay, I mean I don't feel comfortable memorizing formula. I don't think I have done a good job as a student memorizing formula. I always look at building a story around things and relating that with how do I see that in real life. So if I have 2 points, I can just plot it on a graph, on a complex plane, and then I just look at it. I mean, visually also it gives me a lot of clue. Okay? So that's what I would recommend. So whenever I tell you guys a formula, my first attempt is to always tell you how that formula came into existence and how do you relate to it. So that tomorrow if you forget the formula, you don't come to a deadlock. You still have a way to visually or incrementally solve it. Yeah? Alright. So this part is okay. Now, let's look at some interesting aspects of it. So let me quickly see. I have no shame in acknowledging that I have been a very bad person when it comes to memorizing things. So that's why whatever topics I mentioned here that I don't remember. So let me look at it. So the topics that we covered in the previous class were plotting complex numbers that we did, finding the midpoint and the distance. Now, if you have two complex numbers, okay, we'll not try solving it again. It's a visual thing. Let's say we have two complex numbers here and here. If somebody says find out the distance, so essentially what it is saying is find out this length, right? The distance between 2 points is nothing but the length, this length of the line segment, correct? How will you find it out? We have a lot of ways of doing it. Let's say my complex numbers were z equals to 2 plus, let's say 3 plus, sorry, 3 plus 2i, and my second number was 6 plus 7i, okay? So these were my two, so this is 1, 2, 3, 4, 5, 6, 7, and this is and 1, 2, 3, 4, 5, 6, 7, 8. So this is plus 3i, and this is 3 plus 3 plus 2, 8, 8i. Okay. Oops. You guys got logged out. Just 1 second. Alright. So I had two complex numbers. So z1 equals 3 plus 3i, z2 equals 7 plus 8i. So these are the 2 points that we plotted. And when you have been asked to find out the distance, how do you find the distance? Again, very basic concept. Always visualize things in a very simple or as simple as possible way. Keep drawing perpendicular lines. Perpendicular lines are my favorite. And I'm sure it is favorite for everybody, because that makes things look much easier. Now, this one was your z1 and this one was your z2. From this one itself, what is this length? So this length is nothing but the difference between this and this, which is 7 minus 3. You got this as 4. Now, this one is what? This distance minus this distance is your this distance. So, let's say this is 3i and this is 8i. So, here to here is 8i and here to here is 3i. So, essentially this distance is 4i, right? So, what you will do is this square plus this square. Basically, this is nothing but a Pythagorean theorem, right? So, where you will do square of this plus square of this will be equal to square of this. That is your Pythagorean theorem, correct? From a right angle triangle, and from that you can find out. Only thing that you need to be careful about is, see, this is going to be mod of square of this. So square of 4 plus square of this, 4i. Okay? This is going to be a mod of this, meaning you will find out the absolute value of this, and just add them together. Because otherwise what happens is, this I square gives you a -1, correct? You are not trying to find out the value with respect to this one. This is 4i, just a representation here. Essentially, you are looking at this length and this length squared and square root of that. So basically, you will look at the mod of this, meaning the absolute value of this, and then do the square root of that. That's the only thing that you have to be careful about. Otherwise, this will give you, this becomes what? Oh, this is 5i. So this becomes 4 square is 16 plus 5i square. So 5 square is 25, I square is minus 1. So this becomes 16 plus 25 into minus 1. So 16 plus into minus 1 is minus 1, 25. This doesn't give you the right value, okay? So you just have to look at, this is, you have to treat this as a distance and this as a distance, get the absolute value of this, the absolute value of this, I mean square of absolute value of this, square of absolute value of this, and then do the square root of that. Am I making sense or not? Dave? Okay. And see again, my request to you guys would be, if I sometimes force fit an understanding, you have all reasons to ask me saying, no sir, even if you try explaining it, I'm not clear, do it one more time please. So I don't mind doing that, okay? Because this concept has to get glued with you guys, okay? So if I say something in doubt, let me know, okay? So this was about finding out the distance between 2 points. So you have complex number, how do you plot it? If you have two complex number, how do you plot them? How do you find the distance between them? How do you find the midpoint? These are some of the things that we'll be dealing with. Now, moving forward, these are other things that we learned. Okay, if I have a complex number, that is an interesting thing. If I have a complex number z1, a plus bi, or let me put absolute value 3 plus 3i, or 4i. This another term that you'll be dealing with, that is called conjugate. I'm sure Dave would remember because we talked about that in the previous class. Prisha, have you come across the term conjugate?
I've heard of it, but I'm not really sure what it is.
Okay, so conjugate is nothing but a sibling with a different opinion. Okay, so if I have z1 as a complex number, conjugate of that, if I call that as z2, that'll be 3 minus 4i. Okay, so if I have a complex number z1 as, let's say, minus 2, okay, 2 minus 3i, conjugate of that will be 2 plus 4i. Okay, so if you observe this carefully, your imaginary component reverses its sign. That is what is called a conjugate of any number. So this guy's conjugate is this guy, or this guy's conjugate is this guy. Yeah. Now, an interesting but stupid question. Let's see if you guys want to play with the concept. If I have, let's say, one complex number as 3 minus 6i, and second complex number as minus 3 plus 2i. Can you tell me what will be the conjugate of this one and what will be the conjugate of this one?
Would the conjugate of the first one be 3 plus 6i?
Okay. I want to hear that very loud. So when you guys say something, give an answer, okay? Say that, sir, the conjugate for this one will be 3 plus 6i. Even if you go wrong, I will correct it. But when you are saying it, never compromise on the confidence level, okay? That way you will not doubt yourself, okay? How about this guy? Dave, do you want to give it a shot?
Yes, okay, sir.
Yeah, tell me.
The conjugate, we just reverse the complex numbers and be negative 3 minus 2i.
Okay. And Prisha, do you think this is right?
Sir?
Yeah. So yeah, you both are right. Only thing I wanted to kind of reinforce here was that it's only the sign of the imaginary component that matters, or reverses, for forming a conjugate. We don't disturb the sign of the real part of it. Okay? Because no, we always talk, okay, the sign changes. So sign changes sometimes, when we are not in full control of things, we might think, oh, okay, this sign changes, so this guy will change and this guy will also change. So this becomes plus 3 minus 2i. This will actually make us go wrong. Yeah? Alright, now you will say, why we are unnecessarily wasting our time talking about conjugate, right? I mean, we learn complex numbers, we know how to plot it, how do we find out the midpoint of two complex numbers, how do we find the distance between two complex numbers also. Why we are actually wasting our time learning about a new extra term, which is kind of denying my own concept of not memorizing things. Why to learn a new term altogether? So, the reason is this. If I have, let's say, one complex number, 3 minus, why I'm starting with 3 always? See, every day I have a favorite number. I don't know why. Is it because today is Wednesday, third day of the week? Maybe. Okay. Alright. So let's say, let me force myself and say I have a complex number 5 plus 2i. Okay. And then, obviously the conjugate of that will be 5 minus 2i. What actually happens when you multiply two conjugates? If I have z1 and z2, when I multiply them, it becomes 5 plus 2i into 5 minus 2i. And now it is a plus b into a minus b. That becomes a square minus b square. So 5 square plus, minus 2i square. This part is clear so far? Now, what happened here? If you look at it more carefully, 5 square became 25, minus remained minus, it became 2i whole square, that is 4 times I square. Now, pay a little more attention here. 25 minus 4 into I square is nothing but minus 1. 25 minus 4 into minus 1. So 25 plus 4. This whole thing converted to a positive number. Yeah? So, the takeaway from this is, when you multiply a complex number with its conjugate, you get a positive number. Yeah? Or when you multiply a complex number with its conjugate, you get a real number. I mean, let me put it that way. Yeah? 5. Now, there is another advantage of dealing with conjugate. Now, look at it this way. If I have, let me put it in a standard form of a complex number. If I have a plus bi, and obviously the conjugate of that will be z1, this is z2, the conjugate will be a minus bi. So, when I multiply the two complex numbers, meaning the complex number and its conjugate, z1 into z2, I think conjugate is denoted in a different way. I don't recall it exactly, but I'll share with you guys anyways. Or when you kind of do some practice unit, you'll be able to find out what symbol they use. So when you do z1 and z2, what it becomes? A plus bi into a minus bi, which is essentially a plus b into a minus b form. It becomes a square minus b square. Your b is nothing but bi square, which is nothing but a square minus b square I square. Now a square minus b square into I square is nothing but minus 1, right? I is a square root of minus 1, so I square will be minus 1. So this became a square minus into minus 1, that is plus. So a square plus b square. So this is another interesting fact about conjugate. when you multiply a complex number with a conjugate, you get two positive squares. Now you flip this or look at it in a reverse order, meaning you saw this, right? A plus bi into a minus bi became a square plus b square. Okay, just remember this. I mean, remember it just for 30 more seconds. Okay. Now, if I had a situation where I had to find out a square minus b square for a real number, okay, we knew that we can factorize this as a minus b into a plus b. But if I ever had a situation like this, I had no way to factorize it till we had learned about complex numbers or the conjugates. Now I will say, see, we just now, a little while ago, we saw a plus bi. And again, don't think this a and this a are same. We are just relating things, okay? A plus bi is a complex number multiplied with its conjugate gave us a square plus b square. And again, this is a generic term, generic scenario. So this I can always break down and say, hey, this I can say a square minus b square into minus 1. And this is nothing but a square minus b square into I square. So this is a square minus b square. It became a plus bi into a minus bi. So with all that drama and circus we have been doing for the last 15-20 minutes, we could find out a way how we can factorize a sum of squares also. Yeah? Dave, I know it's a repeat telecast for you, but makes sense?
Yes, sir, makes sense.
Okay. So that is why we don't do anything without a motivation. You guys are not going to waste your time in the evening, 7 p.m. with me unless you have a motivation, right? You have motivation that we might end up learning something or we might end up practicing something. That's the reason we are here, correct? Same way, we learn conjugate because of this intent. Because it gives us extra ability to deal with things that we didn't know how to deal with in the past. Yeah? So, let's be selfish. Whatever we learn for a reason. Yeah? Alright. So, up to this much clear? Everybody clear? Alright. Now, if I say divide 16 by 4, easy peasy, fun time, no worries. If I say divide 6 by 5, that is also not so difficult. You can find it out. Now, I will say divide 3 plus, not again, 7 plus 2i by 4 minus 3i. Fun begins. What do we do? I'm saying that divide this number by this number. See, our life was already so very complicated. We are adding more complication to it. Any thoughts, Prisha, Dave? Think creative.
Would you use the conjugate to try to simplify the complex number?
I love that. That's a good thought process. Dave, do you remember?
Yes, sir. Can we just use the denominator and like reverse of the complex?
Right. So exactly. I mean, you guys are spot on with your, at least your approach, okay? And that's what matters when it comes to solving maths. Now, this is another basic concept, right? I mean, we don't really bother to talk about things, but it's very important. Now, let's say if I have 175 to be divided by 25 versus 175 to be divided by 5, which one we like more? We like this one more, okay? Because the denominator is what makes your whole mathematics easy or difficult, correct? Likewise, your approach when you're dealing with a fraction like scenario, your goal has to be to always find out ways to simplify your denominator. If you can simplify this denominator, imagine if this had become this divided by 4 life was so easy, right? We would have said, okay, yeah, this becomes 7 by 4 plus 2 by 4i, yeah? Perfect complex number example. That is exactly what we'll try to do. So, when you have a complex number to be divided by another complex number, what you will do is, you will look at simplifying your denominator. And now that we have learned that when you multiply a complex number with its conjugate, you end up getting a real number. Meaning, you will not have to deal with this messy stuff, right? No dealing with I in the no. See, imagine if you have to divide something like this: 7 plus 2i, 4 minus 3i. Where do we go? How far we can go, right? And at the same time, this becomes like this, our job is done. So, that is why, again, everything relates back to the basic concept of simplifying things. And in a fraction-like scenario, our main attempt would be to simplify the denominator. So, to do that, what you will do, now we know we learned conjugate for a reason. Meaning, if I multiply this guy with its conjugate, which is 4 plus 3i, then my denominator's problem will be much more simplified. So, for that to happen, if I am multiplying it here, then I have no other choice but to multiply it here also. Yep. You guys are with me, right? My tongue might fumble a little bit because of the interesting voice I've got for last few days. But let me know if something is not clear to you guys, okay? So, now my denominator has become like this. So, let's continue with this calculation for a little bit more to come to a logical point. So, this became 7 plus 2i multiplied by 4 plus 3i divided by this square plus this square. So basically 4 square minus a plus b into a minus b, 4 square minus 3i square, which is nothing but, now let's do something in parallel also. Let's break open these brackets as well. So using the distributive formula, 7 you'll multiply with everything, then you'll multiply this with everything. So 7 times 4 is 28 plus 7 times 3 is 21i plus 2i into 4 is 8i plus 2 into 3 6i square divided by, this became 4 square which is 16 minus 3 square is 9 into I square which is minus 1. So this became 28 plus 21 plus 8, 29i plus 6 into I square which is 6 into minus 1 which is minus 6 divided by 16 plus 16 minus 9 into minus 1 is plus minus into minus plus 9. So now what you got is 28 minus 6 is 22 plus 29i divided by 16 plus 9, 25. See, life is not that difficult. Right? So now it will be 22 by 25, which is a real part, plus 29 by 25, I, just complex part. Sorry, imaginary part. So you had a rational form of a complex number, or you had to divide one complex number with another complex number, and we simplified that to get a simplified form of a complex number using whatever we have learned with respect to conjugate. So whatever we did with conjugate, that is actually helping. Yeah. Is everybody with me so far? Okay, so these are the things that we had learned in the previous class, and we kind of repeated most of the things. Let's look at what we have to do next. So let's say next is factoring polynomials using complex numbers. Okay, so let's look at a scenario. Let's say let's see what all we can cover today. We have only 13 more minutes left, and then we have three more topics to be covered within this unit apart from what I've listed there. So maybe next class will be a little loaded class. We'll try going a little fast. Assuming we'll have all these things much more clearer to us. So let me look at what are things. Okay, so we are talking about absolute value of a complex number, factoring polynomial using complex number with the same modulus, and absolute value and angle of a complex number. Okay, so let's look at some simpler concept which is much more relatable, and then rest of the things we'll cover in the next class. So when we say absolute value of a complex number, what does it mean? We have already done that. So if we say absolute value of a complex number, I have a complex number saying not 3 5 minus 2i. So let's say 1 2 3 4 5. 1 2 3 4 minus 1 minus 2. So when we say 5 minus 2i, we are essentially talking about 5 here on the real axis and minus 2 on the imaginary axis. So the point is somewhere here. So I will move this complex number to some other place. 5 minus 2i is our complex number. Okay. So this is my complex number. This is the point. Now, when you say absolute value of a complex number, what we are essentially talking about is the distance of this complex number with the origin. That is how you can look at it. Okay? Which essentially would mean this length. And what is this length? You are talking about this length. This is now your perfect right angle triangle. Okay? You are talking about this length, which is your hypotenuse of this right angle triangle. This is your base, and this is your adjacent side. Square of this plus square of this, and get the square root of that, which will be your this length. So basically what it means is this absolute value of this complex number would be nothing but mod of this. So meaning you will take this length and this length, square them, and get the square root of that, which will be your hypotenuse. So basically you will just find out the perfect length of this, meaning you will do the square of this 5 square plus 2 square, which is 29, the square root of that. That is your absolute length. Yeah, that will be your this one. Now you also might want to look at, okay, so but before I assume that you guys are following me, let me ask that. So is this part clear to you guys?
Yes, sir.
Okay, so basically absolute value of an if you ever come across a term saying absolute value of a complex number, meaning how far is that complex number from the origin on the complex plane. That is exactly what we are trying to determine. And when you are talking about this length, you are not going to get into the complexity of the plus and minus thing. You are just taking the absolute value, right? Because if it's let's say 5 minus 6i, you're talking about this point. So this length will be much bigger. But if you just go by the mathematical side of it, it might look like -6i. This will become negative, and then it's a smaller distance. Don't go by that. You have to always look at the mod, the absolute value, and that is what exactly it means. Now the other way of looking at this would be, what is this length? This length is this length is nothing but, let's look at the real part, which is 5. So 5 is square. This is your base, and this square. What is this? This square minus 6i square, right? This is minus 6i. So you will not say, minus 6i. Let's see what happens here if you don't go with the mod, right? So it becomes 5 square is 25 plus minus 6i square. Minus 6i square becomes 25 plus 36. Minus 6 square is 36 and I square is I square. So this becomes 25 minus 36 plus 36 into minus 1. See, everything goes for a toss. We are not looking at this. So basically what we are saying is mod of this square and mod of this square. That is what should be our way to look at it when we have to find out the absolute value of a complex number. Yeah. Okay. Now, Dave, are you with me, beta?
Yes, sir.
Okay. Now, again, see, complex number is, complex number sounds very complex, right? If you go by the phonetics, right? That's what we call it. Just go by the term, it sounds complex, but it is presented to be complex, okay? It's not actually complex. And if I say find out the angle of a complex number, again, every complex number in the world comes down to a point. And if, let's say, this is the complex number, when we plot in the complex plane, what do you mean by the angle? Meaning, what angle it makes with the origin? Essentially, this is the part, this angle. And how do you determine this angle? Again, the whole trigonometry is there to support us. Draw perpendicular here. This is your base, which is your real part, A. And this is your vertical part, the imaginary part, which is B, BI, whatever. Right? And this is the total length of, or the absolute value of the complex number. You can say that, okay, the angle, if I look at this, BI by A is my tan theta. If this is my angle theta, if this is the angle, BI by A. And what is the angle? Arctan, or tan inverse, whatever you call it. Tan inverse BI by A. That's it. Yeah. So basically, we can relate that with the basic concept. As long as we are able to visualize where does or how does a complex number exist in a complex plane, everything else is relatable. Yeah. Are you guys clear with what I'm saying? So we learned two new things for you, Dave. We learned about what is the absolute value of a complex number. We learned about what is the angle of a complex number as well. So while Dave had to wait for almost like 40 minutes to learn something new, but I believe it was a good exercise to do a recap of what we knew, and I'm sure that would have made you much more confident with respect to what we had learned in the previous class, and something new. So now, complex numbers should not sound complex to you guys, at least with whatever we have learned so far, and there are some more concepts to it that we'll cover in the next class. But before I assume anything, I want to hear from you guys that Is it going to sound complex hereafter or not really?
Not really.
Okay.
Not really, sir.
Okay, good. That gives me reason to be happy and gives me confidence that I'm doing justice to what I'm supposed to do. Yeah. So that being said, I will let you guys go. Enjoy the rest of your evening. Have a good night's sleep. And when you get time between today and the next class, I would request you guys to just go to Khan Academy, go to pre-calculus part of it, go to unit 3, and whatever topics we have covered, try doing the unit test by yourself with the concept that we have built so far. And if you get stuck, that will be an opportunity for us to look at what we have understood well and where we have some more opportunity to learn. Yeah, we still have a few more things to cover in this unit, but maybe you can skim through this unit from the beginning, and you can stop at a point where you think that we have not learned that. And in between, you will have a couple of tests, sample tests to do. That should not take more than 20-30 minutes for you guys, for at least with respect to whatever we have done so far. And I always prescribe you guys to do that because that's our only source of information which will affirm that whatever we have learned, that is learned the right way. At least we are able to apply those concepts for solving things. Yeah. All right. So I'll let you guys go. Have fun. We'll meet again.
Okay, sounds good, sir.
All right. Bye bye. Good night.